Howdy students, we are at Inscribed Angles Phase 2, and to start this we're going to look at an inscribed quadrilateral. So on my screen to the right, this is an inscribed quadrilateral, and look, just to show you that I didn't predetermine this, I can make it whatever I want to look like. Wow, pretty neat. That's a good looking quadrilateral right there. Alright, it's inscribed quadrilateral because notice like this blue, pink, red, green, all these angles, they're inscribed angles and they just happen to form a quadrilateral. Alright, so what do we think's true? Like, what's the relationship between the green and pink angles or the blue and red? That's what we're investigating. In fact, there's a specific relationship, and we could do a two-column proof if we wanted. But notice how if I slide and put these angles together, oh my gosh, they form a linear pair. Alright. So what do we think is true about opposite angles in inscribed quadrilateral? Well, when we push them together, they form a linear pair, but specifically, because they're not together when they're in their actual spot, they're supplementary. All right. Opposite angles in an inscribed quadrilateral are supplementary. But if I make this like a goofy looking one, like something like that, will it still be true? The answer is, well, yes, it still is true. All right. So that's pretty interesting. All right. So we actually have this cyclical quadrilateral theorem, which we can find in our iBook, but I don't really feel like using the iBook. All right, let's just get this nice big screen so you can see everything. All right. So let's just make some random points. All right. Now let's see how good I can do this. Actually, that's not going to work. All right. Oops. We'll have to hand do this. All right. So I got some random quadrilateral. All right. I'm going to name this quadrilateral math. Get it? All right. All right. If math is an inscribed quadrilateral, I'm just going to write quad, then opposite angles are supplementary. All right, so what does that specifically mean? It means the measure of angle M plus the measure of angle H equals 180 degrees. Measure of angle A plus the measure of angle T is 180 degrees. All right, that's it. That's the punchline. All right. Now, something like that's kind of cool is like, let's focus on angle T. All right, angle T, and it relates to this arc over here. All right. Remember, this is half of, that's actually right. This angle measure is half of the arc MAH. All right. Then if we focus on angle A, the opposite one, well, this arc right here, remember, it's half the arc, and we'll do a minor arc for this one, MH. Actually, we'll say TH, just to be uniform. All right, so realize these inscribed angles are half the opposite, or their intercepted arc. Well, both arcs are add up to 360, so it's just really 360 divided by 2, and that's actually where the 180 comes from. All right, these inscribed angles, their intercepted arcs form the full circle, so that's why they are supplementary and add up to 180 degrees. All right, and this is the punchline. Here's just another picture, all right, if my picture wasn't good enough. But anyways, let's go ahead and start applying it to some stuff. We got some very basic problems to start, and we'll slowly graduate to more challenging problems. So cool. All right, so again, identify this as an inscribed quadrilateral. All right. Next, opposite angles are what we're focusing on, X and 180. All right, so for instance, to find X, it just literally, X plus 80 equals 180. Subtract 80 from both sides, x equals 100 degrees. All right. Now this is kind of a simple problem. You might have been able to immediately tell that it was 180 degrees, but nonetheless. Then over here we get y plus 71 equals 180. Subtract 71. And 109 degrees. All right. So that's it. All right. Opposite angles are supplementary. That's a tier 1 basic problem right there. And the fun fact is all the angles on quadrilateral add up to 360 degrees. All right. Over here. Now this one's a little bit more challenging, a little bit more calculations. Let's just go ahead and focus on this inscribed quadrilateral. Z appears to actually be the easiest one first, all right? Because to find Z, it's going to be 93 plus Z equals 180 minus 93 minus 93, Z equals 87 degrees, all right? Now X and Y, let's write this out but then talk about it. X and Y, they add up to 180, but we don't know X, we don't know Y, so it's impossible to find them both at the same time. However, if I focus on this right here, angle X is an inscribed angle. The intercepted arc is add these together. This whole arc right here is 164 degrees. All right. So that means that to find X, we got to divide by 2. So it's going to be 82 degrees. So X is 82 degrees, and then I can immediately find Y after that, where Y is just going to be 98 degrees. So let me circle all my answers, specifically say X was 82. All right, and then we got this last problem right here, and looking at it, what do we got? Hold on one second as I get situated. All right, so now I'm ready to go. I had to check something super fast. All right, again, inscribed quadrilateral. All we got to do is focus on opposite angles. Let's just do this one first because that's what I looked at first. And let's write out what we got and see if we can solve it. We got 105. We got 7x plus 1. They're in fact supplementary. And we only have one variable, so we can go ahead and solve for x. And remember, the first thing we always want to do is try to combine like terms. CLT. So we got a 105 plus 1, so I got 106 plus 7x. All right. Then divide both sides by 74. Subtract 106 from both sides, and we're going to get x equals 74 over 7. A nice little fraction. All right. Then we're going to focus on that stuff right there. We got 4y plus 14. We got 7y plus 1. It's going to equal 180. All right, those angles are supplementary. Again, the first thing I want to do is combine like terms. So 11y plus 15 equals 180. Bunch of math happens. We're going to get 165 divided by 11, which I believe I know the answer, but let me just double check. Yep, y equals 15. All right, so that's how you do that problem right there. All right.